So let's talk about architectural lighting and building systems. So, first of all, what is lighting design? And that is a really good question because that's what we're going to spend the semester learning. And first of all, there's a couple of things that you design when you design with light. There's the quality of the light itself. And if you think about it, the kind of character of a light that you see when, I don't know, you walk into a classroom and it's all fluorescent light overhead. That's a certain character, as opposed to if you're at a campfire and everyone's face is lit up by the campfire light. That's what I'm talking about when I mean the quality of the light itself. It can be quite different. Then, of course, when you have decided on the quality of the light, you also want to decide on the reflective properties of materials. Now, most people call that color, but I have a thing, and so does your textbook, has a thing about materials. They're not actually containing color within their, I don't know, physicality. Instead, it's reflective qualities and or reflective properties. How shiny are they, but also which wavelengths of color do the materials reflect? Some materials reflect certain wavelengths, but only scatter other wavelengths and then absorb other wavelengths. So each material is quite different. Finally, the fun part is the light delivery systems, which is all the kind of tech that is needed to make our lighting dreams come true. So first of all, let's just talk about these different parts. And light comes from a source somewhere out there, who knows where. Now, of course, the most primitive light source that we know of besides the sun is fire. And of course, in this class, we're going to be talking about both natural and artificial lighting. But in this case, I'm talking about artificial lighting. And of course, these are matches burning. But incandescent light, interesting enough, is actually quite closely related to fire. If you look at the lamp here, and from here on in, we're going to call light bulbs lamps. You'll also notice that in the introduction to the semester in the textbook, they mention this as well, that light bulbs are a thing. That's the glass part around the filament. And the filament burns. It's actually just a wire that's wound very tightly in a very narrow spiral. And that spiral, by passing electricity through it, it just gets real hot. And essentially it burns. And in fact, we know that incandescent light bulbs, or lamps, burn out. And you can see the little filament inside. And in fact, if you have a clear bulb on your lamp, you can even see the little bits of filament that have burned out and are just kind of charred messes on the bottom of the lamp bulb. There are different kinds of bulbs out there, and of course, I'm sure you're all vaguely familiar with these different kinds, although you may not have looked all that closely at them. This one is kind of a pain. Nobody likes this one. This is the sad stepchild here. This is a compact fluorescent. It's an interstitial technology that got us from the kind of low efficiency incandescent lamps. It got us to where we are nowadays, which is with LED lamps. Now, all of these lamps, and these are all compact fluorescent, here can be made in all sorts of different shapes. And what you'll see is that these light output devices are designed for a number of different tasks. And of course, they're also limited by the kind of physical nature of how the light is produced. In this case, the light is produced by a tube with chemicals coating the inside of it and electrons passing through it. So it has to be, or has to contain, some kind of tube shape. Now, these days, here in the 21st century, and really pretty much within the last 5 or 6 years, LED lamps have been the light source of choice. And this is an LED lamp, which is configured to screw into a socket like other kinds of lamps, incandescent, compact fluorescent. But it operates in an entirely different principle. No longer are we burning anything or shooting electrons through a tube. We are now basically having a printed circuit, which by the nature of the kind of wafers in the circuit, it glows. And those little yellow spots that you see, those are the LED emitters which glow. And LEDs can be configured into old-style incandescent screw-in lamp configurations, even though they do look a little bit funny. If you look at some of these, they're kind of oddly shaped. It's like a tube with a lot of yellow dots on it. So LEDs are kind of their own special world. And again, we'll get to that when we talk about the technology later on. So light also has color, and I think it goes without saying that when you look at a light source that is tunable, and this can be everything from something architectural, like I'm picturing here, a glass block wall with LEDs behind it, to even just those Halloween hair implants that you can wear that can change colors, or a jacuzzi with changing colors. And I think that perhaps 15, 20 years ago, funny colors like these were considered a bit gaudy. But nowadays, especially as you hunt through the magazines, you will see more and more use of great variety of color. And really, there's one reason for that, and that is that LED lamps can change color, or at least you can specify ones which can change color. They can be tuned. They can be fully white, but then you can also tune them to have R, G, and B, red, green, and blue, mixed in any kind of infinite level of configurations. So, and this is from a shopping mall. And again, these colorful uses of light in your interior can really make a splash, can draw a lot of attention to themselves. Now, another fun feature of light, fun if you find these kind of things fun, is that it can be measured. And this is one of the few instances in design where you can basically say, yeah, it's working, or no, it's not working, because we can actually measure the light level. And when we get to that section of the semester, you will see that there are apps that you can use on your phone to measure ambient lighting. And you can also use the computer to do calculations. And we can measure both the sort of power of light and also the wavelength. And one of the reasons that different light sources are are better or worse at showing color is because of the spectrum of light that they emit. And we can measure that. If you look at these different spectral distribution charts for different light sources. Some light sources are very smooth and have an even curve in their light distributions. They have a little bit of every wavelength. Other light sources, such as fluorescent, are going to have spikes. And that's why if you, say, put on makeup or clothing under fluorescent lights, sometimes you're tricked. Certain colors don't look good. And in fact, retailers know this, and they know that if they're going to be lighting their store using a light source that has this spiky quality to it, they're not going to have clothing that has color that looks funny that way. Now, light has to have some kind of delivery system. Even natural light only works in an interior if you have a window. It's awfully dark without a window during the day unless you have some kind of delivery system. And of course, artificial lighting, we are always trying to find a light delivery system. And by this, I mean the lighting equipment. The luminaire is the technical term. We want something that has an aesthetic that goes with the aesthetic of our project, but that also delivers the light in a manner which we want for our kind of design goals. Is it going to be something where the light fixture itself is going to garner our attention? And these are all decorative fixtures here, kind of a hodgepodge of fun-looking fixtures. They all want your attention. They want you to look at them, and they kind of glow. Whereas other fixtures, this is a recessed adjustable can, all we see is a little white ring in the ceiling, or whatever shape aperture that we choose. most of the light fixture is hidden above the ceiling. And in fact, the vast majority of architectural lighting is hidden. The light source is hidden, and you want that. You don't want people looking at your light fixtures. You want them looking at your kind of architecture. So light also has tasks. It has a job to do. It's a working feature of our designs, and obviously a task lamp. That's why we call them a task lamp, because they are adjustable and can get the light right where we want it, right where we need it to actually do some sort of activity. But even something like under-counter lighting, there's a reason we have under-counter lighting, not just because it looks cool in our architectural renderings, but it also because that's where the action happens. You're chopping with sharp knives, and you don't want to chop your fingers off. You want to chop, your parsley and whatnot. So those lights are referred to as task lights because they're aimable. They're focal in that they can be focused on something. And the book does actually refer to them in both ways, focal and task. Even something like a sculpture, you can't just pop a light on it and have it work. You have all sorts of things to consider, including sight lines so that you don't have glare, and the shape of the sculpture, and what sort of light is going to show it off best. Finally, we have the power, thanks to the computer, to model light on the computer using our fancy schmancy software. And in fact, very frequently, we try on our computer the biggest struggle with getting Revit, for example, to render, or Enscape, which is another kind of tool that we have, is to get the lighting to work. That's probably the number one source of frustration. Number two is the materials. And of course, the materials and the lighting are related. If you use the wrong color temperature in your lighting, if you remember from your Revit settings, then everything looks yellow. It doesn't matter what color your material actually is and what its reflective properties are. Everything will look funny. Finally, lighting, when we talk about it in terms of architecture, there are a number of very common architectural strategies, and I can never resist a chance to get in my next pet peeve, which if you've had one of my classes before, you know I have a couple of pet peeves. And one of them is that we often talk about wall washing, but what we end up with is scallops. Scallops are those kind of, upside down U-shaped light blobs on the wall. I'm very proud of this picture that I found that is just absolutely the worst scalloping. Those even look like they're supposed to be wall wash fixtures. A true wall wash, and again, this is a very common lighting technique that we'll use in our interiors, the wall has an entirely even layer of light on it, from as even as possible from top to bottom and left to right. There's no shadows, there's no scallops, and in this case, it's used in a gallery, and you can see that the advantage of this is that it's incredibly flexible. You could hang paintings anywhere on that wall, and they would be well illuminated. Now, you can also use lighting in your architecture, in your designs, to either focus attention on some object or divert it. So, for example, if you backlight objects, you can call out their shape instead of their color, whereas if you use spotlighting on in this case, the chair in the foreground, it's really red, so it grabs your attention. You can also use lighting in a social setting to gather people's attention. Now, the brightest thing that we see here is the kind of bottles on the wall that are backlit or that have a very pretty color. But really, if you're sitting in this space, you're probably sitting across from someone with a candle in between you. And okay, sure, it's probably one of those battery-operated candles. But what that does, we as humans, we are sort of almost genetically predisposed to be drawn to light. And when we have a light source that's in between people, in between a group, it lights up our faces. And of course, we're also drawn to human faces. So this is why even in the cheaper restaurants, they're going to drop a little candle on that table, because it creates a social grouping that wasn't there before and that you can't achieve with overhead lights or other things. It needs to be a light source that's kind of in our field of view. But there are plenty of other situations where we can use lighting as kind of a trick to draw attention. This is just a boring corridor. But what they did is, instead of just like, all right, we'll pop a couple of light fixtures up in the ceiling and we're done. We're going to light the floor. Instead, they have a message on the floor, which I believe can change, and they have glowing strips on the floor. It's just a corridor. It's just boring, and you're just passing through it, but it does make it more interesting by using lighting techniques that are kind of fun and dynamic. Or even a space like this, extra credit if you can figure out what the specialty of this restaurant is. Of course, it's wine, right? They have all the wine bottles prominently lit. The labels are turned forward and they catch the white light. In fact, I think if you go through and you look at this space, there are kind of layers of lighting. There's lighting on the bottles, but actually the brightest spot in this space is probably the tabletop. And if you remember from the candle slide, having that bright area in between you really helps to create a social environment. Now, in this case, it's a restaurant, not a bar, so you're probably going to have a lot of service and things like that. Also, it's a larger table, so in order to facilitate kind of cross-table conversation, those bright downlights on top of the table are going to have to do. A candle would just get in the way. And probably burn the place down. But anyway, and then there's lighting on the painting in the background, and there's even some spill light up on the ceiling. So this is a very sophisticated kind of layered space. Some of those layers are brighter than others. They are tuned so that your attention is carefully controlled. You're drawn to the social grouping around the table, but as a backdrop, there's that lovely painting and the wine bottles. Now, in addition to the kind of social aspect, we can look at the architectural form and how lighting can be used to either emphasize elements of the architecture, or it can be used to kind of accentuate volumetric qualities. In this case, they've used skylighting in conjunction with these kind of green, wayfinding strips or something. I'm not quite sure what you'd call them, but you can even see there's kind of a light distribution coming off of the skylight. And at night, I'm sure that these strips can have LED light strips up in them, so you get the same effect. Again, it just kind of breaks up the corridor and probably has something to do with the organization of the project, demarcating different nodes along a circulation path. Or something like this, where it's a connector space between two wings of a library by uplighting the ceiling and making the ceiling very linear. What you're doing is kind of creating a visual connection in between these two wings, just by kind of leading from one to the other, the linear nature of the black kind of stripes in the ceiling. Or even something like this, which is just an interpretive center. All the lit up signage is in the floor, which is kind of an interesting way to do it. And one of the benefits of that is that the spill light from this interpretive signage lights up this very kind of dramatic and softly curving ceiling. And they've done a good job of getting rid of all the ductwork and hiding all the sprinklers and other things up in the coffers. But nonetheless, it's, again, a nice way to call out the interesting architectural volume. And finally, in some types of spaces, you're going to have light sources, particularly in large circulation spaces, or in airports, for example. You're going to have lighting fixtures that are really, they are indistinguishable from the architecture itself. Even in spaces like this, a concert hall, we're not focusing on individual light fixtures here. We're really looking at the volume that is the concert hall by lighting the roof above the ceiling grid. Besides creating an interesting silhouette, it kind of creates a greater sense of height in the space. And of course, it's not a very big concert hall, so you're kind of getting a little more space for your money just by some clever volumetric lighting. This is an airport, and well, if you've got an airport and you have to have 1,000,000 light fixtures up in the ceiling, why not make them look like wings? And of course, obviously the symbolism is great, but also airport lighting, you just need a lot of lighting on your circulation zones because people are trying not to get lost. They're trying to read their tickets. They're trying not to walk into each other. So having giant areas, giant banks of lighting is kind of necessary in this location. So light can also be used to expose texture in your materials. Remember I mentioned that materials have a reflective quality. Well, if this same boring beige color was just wall paint and glossy, it would be very different than this beige colored stone. Or even in a space like this, where you have kind of different planes, each with a different texture to it, the lighting can really help kind of reveal that texture, or not if you want to flatten textures that you don't want to see. So finally, light can also help you define circulation patterns. This is a department store in Korea. Very interesting way. And again, you already have to have a lot of lighting along circulation areas anyway. Why not use it to help people know where they are in the project? Or in something like this where they are organizing the kind of one of the axes along the project. In fact, I love that they even have turned the chairs so that they're all along this axis. The flooring aligns with the slit in the ceiling, which aligns with the window in the wall. Gotta love it when everything aligns just like that. Or even something like this, a circular space tends to be a static space, like a dome. You tend to want to stand under a space like that. Why not have the lighting match that? And of course, they want you to buy the expensive products that are right in the middle of your store. And one more view of that library that I showed earlier. This is a view from up high, and again you can see how effective these linear lines up on the ceiling, how effective they are at kind of drawing you through a space. They really make you want to walk through. And by the way, they are lit from those kind of piers that are off on the right side. Even a kind of sketchy, ugly space, which is a passageway between two buildings, by creating some bright lighting and using bright reflective materials, it makes it a much more dynamic space. Instead of just being like kind of a creepy pass-through, it's now actually a fun and interesting space, and it also feels a little more dynamic. So the other fun thing that we can do with lighting in our interiors is we can take advantage of the fact that light changes during the course of a day. Now, of course, this is natural lighting that I'm talking about, and this is the light from the oculus at the Pantheon in Rome. And basically, it's a hole in the ceiling, but of course, the light changes. The location of that spot moves along the wall and the floor as the time of day changes, and of course the time of year as well. The altitude and azimuth of the sun change during the course of the year, and this is very healthy for you to experience the changing light qualities. This is Tadao Ando, a very famous Japanese architect who loves using skylights in very subtle ways. In this case, that check mark moves up the stairs during the course of the day. Or this very lonely pair of chairs in a courtyard. I actually don't really think I would want to sit there, but you can see how dramatic the shadows from the skylight are. Or in this case, he's got side lighting, light coming through the window sideways, but also a skylight along the wall, essentially creating a wall wash at different times of the day. And even artificial lighting. This is Pablo Picasso drawing with a light, with a flashlight. And many kids, I'm sure when you were kids, you might have tried this, where you have a long exposure and you try to sign your name using sparklers or something like that. A very fun thing. And we can do that in our architectural lighting. We can have lighting which is brighter or darker during the time of day. Even our phones change color when the sun goes down. Usually, if you have an iPhone, it has something called night shift, where it shifts away from the blue, and Android phones have something similar. Finally, light can have meaning, and we can use it in symbolically. Go into the light, right, is the line from the movie Poltergeist, which is famous, but also obviously religious situations. You're going to have lighting. This is the Ronchamp Chapel by Le Corbusier, and stained glass, of course, has a long tradition in the Christian church. But even this is a Dutch Reformed church in Holland, and they still use light, although the articulation is quite different. And this is a more modern church, which I can't remember where it is. But again, the symbolism of the lighting is very powerful. Obviously liturgical in this case, but even the ground zero shafts of light, which they put up, I believe, within a year or two of the Twin Towers coming down. I think Howard Branston was the lighting designer. He was a kind of a big shot lighting designer in New York back in the day. And it symbolizes kind of rising from the ashes. And again, the symbolism of the lighting can be so powerful in your projects. So for all of you, this semester, really my goal is to have you learn how to use lighting to not just to kind of enhance your architectural ideas and architectural designs, but really to incorporate it right into kind of the base of your projects, to design with lighting as one of the primary considerations.